Let's talk about AI in a less methodical way. In terms of thoughts and consciousness, sometimes the way we feel and express ourselves can't be put into words. We might need things like art or music to describe the more abstract nature of our thinking. Because code is written in a language that we can develop and comprehend rationally, that might not work out so well. To give an example in myself, I've been doing art for a long time. And perhaps some of the stuff that I draw is a bit bizarre. And some of it might even have some kind of expressive subconscious meaning behind them. In ways where I can't convey my thinking in words or in math, I need to tell them in a more artistic manner. So well, sometimes I want to draw something maybe realistic or some kind of architecture. Sometimes I want to draw a rooster with a tennis racket up its ass. I don't know. The point is that it's a personal and a communicative way of transferring my thinking or to something that's tangible, not being limited to dialect. So suggest I told you to draw your emotions at this given moment. You could surely come up with something, some kind of representation, some kind of expression of yourself, but give the same task to a highly developed AI and, well, it probably wouldn't know what to do. If anything, it would get confused and start drawing in binary. When limited to only algorithms and math, creative expression becomes a lot more challenging.
I've heard this discussion, this argument, this debate that an AI singularity is inevitable. It's eventual. It's gonna happen whether we like it or not, regardless if we like it or not. And by the AI singularity, I'm referring to when machines or androids have very little to zero differentiation between man on every basis, intellectual, emotional, behavioral, basically where man and machine coexist as equals. Think of it as a sort of evolution or an exponential growth of technological development, where it reaches an extent that an AI outwits its preliminary creator, which sounds like it shouldn't make sense. It sounds like a contradictory statement, but it's not entirely impossible. I would just make the argument that it's improbable to happen, anytime soon at least. Think about how illogical that sounds. An AI singularity, a machine AI advancing enough or to the extent that it could rival or even surpass the intellect of its creator or its inventor. Comparing intelligence like that seems like a fallacy, and going as far as comparing behavioral and emotional traits seems out of the picture. And I just sort of wanted to address these preconceived notions of AI. The thought that it's an inevitability or a fact, some kind of certainty that an AI singularity will eventually happen and not an idea or a concept sort of baffles me. It may very well be an inevitability, but it's a question of when or how. Maybe it's movies like Ex Machina and Her that exaggerate these concepts to start with. On a relatable note, I always found it amusing how movies go about dealing with the development of exceedingly intelligent robots, like how they make these machines to aid humans. That's their purpose, and they give them very normal, standard features like being programmed to do things well, like cleaning your house, folding the laundry, feeding the cat maybe, all while simultaneously able to
make your trip as comfortable as possible.
Excuse me. Don't disturb my friend. He's dead tired.
It can do all these very mundane things, well. Also, for some reason or another, able to leap hundreds of feet in the air and run at incredibly fast speeds, and it doesn't make any sense. I'm looking at you, iRobot. It doesn't really matter. Even more realistic approaches, air quotes, realistic approaches to this topic don't do a very good job at convincing me, and that's what I wanted to sort of talk about. So firstly, let's talk about computers. Let's investigate computers, because after all, we are comparing man to machine. And humans, or any kind of sentient beings for that matter, behave in a very dynamic or spontaneous way, a way that's entirely opposite to machines. Machines are, and always will be, very methodical, pragmatic, and logical. And I'm not saying this with any kind of doubt. I I'm a software developer, I'm a software engineer. It's up to me how the end product turns out. And simply put, machines or computers are incredibly stupid and can't do absolutely anything by themselves. The programmer is the one who gives the orders. These orders are written in code. Code is always written in a very algorithmic, logical manner, continually, and after everything is compiled to ones and zeros, the computer just executes the information. So scientists want to reverse engineer the brain, reverse engineer human thinking as we know it and transfer it over to machines. Fantastic. Reverse engineering regions of the brain, like maybe the visual or auditory cortex, may seem relatively unpretentious compared to recreating something like say the cerebellum or the cerebral cortex, where recursive thinking and skill structure is developed. And not only that, but more complex attributes like artistic progressions are immensely challenging to reproduce. But anyways, I digress. The problem is, however, all of these processes that take place in a machine are usually Boolean algebraic ones, meaning the machine just follows a series of logical statements, on or off, true or false, if and or else, do or do not do, depending on the operation, of course. But it's always the programmer that governs the way things ultimately work. So if someone were to theoretically make an AI, the question is, would it be its own unique thoughts and opinions, or its programmer's responses given as a default answer? And if it were to be a dynamically given answer, you would still have to derive from somewhere, either from an online database or what have you. And even in that case, the answer is still fabricated. It's still relayed from an outside source. And you can make the argument that humans do the exact same thing, regurgitating the things that we hear and modifying the response to something that's seemingly our own. But it's more complicated than that. It's a lot less assigned. It would be very challenging to program a machine that, for example, could think and behave dynamically. And I'll give you a simple analogy or a reasoning to why this is. Humans can be fairly spontaneous or random, for lack of better words. Whether it's for the good or bad, we as humans aren't perfect in this regard. Machines, on the other hand, cannot do random. And what I mean by this is very literal. In almost all programming languages, there's a built-in function that generates a random number. This random number, you can do whatever you want with it, but the number can never truly be random, meaning that it's only pseudo-random or seemingly random. It's a number generated by a series of mathematical operations induced by many variables. Regardless of how complicated it may be, it's not true random. And a machine's behavior can always be determined mathematically because of this. It's only possible to generate truly random numbers by measuring things like truly non-deterministic fluctuations known as noise. This can be sampled into variables that are actually random with no chances of predictability. Natural events in life and humans as we know them are like this, non-deterministic. Machines or computers, on the other hand, are deterministic, predictable patterns that can be studied and reproduced. Software and games all use these seemingly random generations. They all start with an initial number or seed number that later gets applied to whatever kind of random number generation formula you want. Whether it's some kind of middle square method or something else, the same seed, the same series of numbers, the same variables and events. The easiest way to picture it would be like an encryption or any kind of security measure where you can work backwards from. If you know the initial number or seed number, you can basically decrypt your way back to where you started. Games use this for random dungeon or map generation. It's not truly random, it's overseen by many variables. Most important, the first one, the seed. You get the same seed and the map or world is identical. That's how multiplayer works for randomly generated games like Minecraft, as well as other games with a huge emphasis on randomness like Path of Exile, for example. The larger the initial seed, the more complicated or secure the encryption, map, or level becomes. The point of all this is that random numbers aren't truly random. It's a mathematical process like everything else and has a formula and a set of logical processes to produce an outcome. And if you're using this for a machine or a machine's behavior, then the same rule would apply to the machine. The same logical operations to produce an outcome. The outcome is assigned. And if you know the formula and know how to use it or how it's applied, then the outcome can be precisely predicted, unlike the behaviors of, say, humans. Things like emotions are unlikely to transfer over well in AI because of this, and even if small problems like this are hindering the outcome, the idea of making a dynamically behaving and thinking AI is an incredibly more difficult task. This entire spiel doesn't take quantum computing into consideration. I know that qubits work in an entirely different way from the traditional binary means and are strangely nonlinear in determining a conclusion. The point is more so that it still needs to arrive at a conclusion formed and developed by a person. But a computer is still a computer that calculates and executes code written and designed by humans. Therefore, it'll be very difficult to surpass the human, because it was the human who initially created it. And people will argue that, but quantum computing isn't limited to either ones and zeros. It can be both at the same time, making up for the spontaneity in programs. It's a complicated and a faraway science that's hard to talk about now and probably deserves an entire video, so let's not go there. We'll stick to analyzing the more traditional means for the sake of this video. My point being that humans are random in a lot of different ways. Say, for example, emotions. Happiness may just be a chemical reaction happening in your brain, triggering a reaction pertaining to whatever it is that made you happy. You can simulate something like this in a machine, but the problem isn't how, but what. How would you determine what makes a machine happy? What instance would trigger or flag an event of happiness in a machine? For humans, we can be flawed, sure, and while some maybe find cat paws or coffee give them a sense of enjoyment, others might find thrill in murder. So if a machine were to have the same level of dynamic emotions, there would need to be a limit put in place for what gets triggered and what doesn't. Like how we deal with criminally insane patients in an asylum, these dysfunctional machines would have to be considered errors in the process. This becomes hard because in many ways, objective good or bad is a dialectical fallacy. It doesn't and shouldn't make sense. You can't define what is good and what is bad. You can only have a census agreement, which is always changing and arguably still unreliable. The problem with this is that we go back into engineering the way the machines behave, making it less realistic or a less realistic representation of life and more of a machine, going backwards and reaching this singularity. The ethical and morality implications would be just as strenuous as the development, hypothetically speaking, of course. I say it's unlikely, so let me give you a realistic example of why developing exceedingly smarter AI is a struggle. So let's look at Moore's law for a second. CPU processors, a graph showing the gradual incline of logical units or components per integrated circuit. Great, so it seems to be fairly steady until recently, where CPU developments are taking longer than ever before, and almost like a plateau, we hit a wall, and now advancements are far and few between. In this graph, we can see that CPU clock speeds are becoming increasingly more difficult to develop. Moore himself was quoted even predicting this saturation, saying, "I see Moore's law dying here in the next decade or so." And now we can clearly see the flattening or exertion needed to further advancements. The reason I bring up CPUs is because it's the main processing unit. It does all the math, it does all the thinking, it's the brain of the computer. And in the same way how we hit a limit or a slowdown in development, presumably much of the same will happen with the development of AI. The time it would take to, say, develop an AI with an IQ of 20 to 50 might not take as long in comparison to the time it would take to get it to 50 or to 80. It's basically Moore's law in relation to AI advancements, predicting a hurdle in the future. On a side note, if Moore's law of exponential growth in terms of computer power was a constant influx, it still wouldn't buy you much. The scale of power needed is that immense, not just by figurative CPU power, but by very literal power consumption. While your massive brain may take something like approximately 20 watts, a single small CPU is normally over 100 watts. Get a bunch of CPUs and put them all in a series, the same volume of a human brain, and you'll probably either get a power surge or a fire. comparatively speaking. Thinking back, IQ scores are a perfect comparison. It measures, or I guess benchmarks, the capabilities of our brains in a very computeristic way. Like with benchmarking a CPU, for example, we give it many mathematical and complicated arguments it needs to solve within a given amount of time, like how an IQ test might work. Our brains work the same way. We're given number sequences and pattern predictions to test how quickly we can problem solve. That's where the similarities end, however, because what we perceive as smart or genius doesn't necessarily mean high IQ. Some low IQ patients suffering from severe autism have or may have photographic memory and are able to accurately replicate everything they've seen to the smallest detail in their drawings or paintings. Genius doesn't or wouldn't be defined by a single score in all circumstances. To some, intelligence quotient scores might not be as meaningful in the end product when building an AI because, well, we have the means and formulas of developing intelligence. How would you develop things like compassion or empathy or love? We can put intelligence in a variable and compare wits, but not other factors like love or emotions because they're concepts. And how are you supposed to program concepts, program ideas? That's why many theorists fear the AI singularity. The idea of an all-intelligent AI who understands no compassion or remorse is a recipe for danger, as they see it. To build a program of a humanistic AI, you would need to in turn build and construct the formula to life as we know it. To make matters even more improbable, some scientists perceive intelligence as something that has the possibility of becoming increasingly expanding without a finite end. The idea of infinitely gaining knowledge is due to the idea that machines just never die. They keep advancing and refining their knowledge, so that if a machine that was already highly intelligent in the first place manufactured, or I guess technically speaking, reproduced an offspring with an IQ that was 10% higher than its predecessor, and this loop kept going on and repeating, we would then technically or theoretically reach limitless knowledge eventually. It's hard to conceptualize, but picture a machine that's become intelligent enough to figure out a way to advance microprocessor technology. And this said advanced technology becomes implemented in the later models, or the code is rewritten better, faster, more concisely, continually repeating and looping, improving knowledge. That is until the inevitable AI world domination apocalypse.
Hey, you gonna pay for that?
Talk to the hand.
So, well, we do have self-evolving algorithms for things like cars to drive on their own and improve as time goes on. The idea of making an AI that can think for itself and create something entirely unique, like another comprehensive artificial life form, is a bit of a stretch. So this is why it's difficult to imagine artificial intelligence with the same level of intuition and behavioral traits as humans. But let's suspend our disbelief and hypothesize. Let's presume, hypothetically, that we developed a fully capable, dynamically behaving and thinking AI and ask a few questions. First, I want to make an analogy to Star Trek. You may recall the infamous line, "Beam me up," where crew members are basically transported around various places and locations in the show, but there's been a debate of what actually happens during this transportation process. The reason of this is that in the world of Star Trek, beaming something or someone means that you are converting that object or that person and all the properties that make it up into energy, which then gets transferred. This energy accumulated can then be assembled and reassembled in different locations. This entire process is called dematerialization. The problem doesn't lie so much with transporting objects, but with people, because if we were to convert every single portion of a person into energy and transmit everything as it were somewhere else, is that person the same as they were before they were transferred? Does a part of them die in the process? At what point do all these little bits of things make you? Sure, the body as an object, various brain components, physical properties would, but what about their memories, their souls? Would that person lose something in the process that can't be converted into energy is the question. And it ties into developing a humanistic AI because if we were to theoretically create a model of a brain, feelings, and emotions alongside other more physical components, the most quintessential portion of creating a formula to life is still missing, the soul. Whether you believe it or not, whether you describe it as a subconscious awareness of self or a spiritual material for all life, it's something that wouldn't be or can't be converted or replicated in science. An interesting line was spoken from the puppet master nearing the end of the first Ghost in a Shell movie, where he says the following: "In life, when organized into a species, relies upon genes to be its memory system, so man is an individual only because of his tangible memories. And memory cannot be defined, but it defines mankind. The advent of computers and the subsequent accumulation of incalculable data has given rise to a new system of memory and thought parallel to your own." If anything Ghost in a Shell did great in, it was discussing the more philosophical and psychological properties of what makes up a person. These sort of questions are essential to understanding ourselves as humans, so that we can then project our image to the descendants of the AI. Basic instincts, morality, the properties that define a soul. Where did they originate from? Or was it something that was always there? With something like morality, some could argue that it derived from religion or some other set of ancient guidelines. That's why concepts of religion or spiritual connection to oneself, in anime particularly, works so well for me. Take Evangelion, for example. Well, most giant robot mech anime shows don't have a deep, ingrained connection with their machines. It's mainly just used as a big war tool. But in Evangelion, the fact that each Eva unit is prominently flesh and blood, sometimes even acting on its own, and the idea that the connection between the pilot and the Eva was a spiritual one, with the main joining being the soul, was an interesting premise. That sort of showcases a differentiation between the two, so much so that some have a hard time even considering Eva a mech. The reason given in Evangelion to why the mother's soul, or Yui's soul, was in the Eva core in the first place was to be eternal proof of humanity's existence, the soul being the proof. In a Discord chat, someone had mentioned how synthetic intelligence was used instead of artificial intelligence, so not to offend the machines. Offense being either an impulsive reaction to a series of words or something that was initially programmed. And if it's the second option, which it most likely is, you can simply program the machine to not feel offense for being called inferior to man. If not, be careful not to offend, because it would probably mean certain death. Machines have no sympathy. A pseudo-singularity is the closest thing we'll ever get.